Sir.
Yes, yes. Thank you very much. Yeah, you are audible. Thank you. Okay. Good morning, everybody.
Good morning, sir.
So first of all, let me. Am I audible?
Yes, sir.
Okay. First of all, let me apologize for not coming in person due to my personal reasons. And big thanks to Dr. Chittaranjan Malik for giving me this opportunity through online mode. And he has asked me to give only for 10 to 15 minutes. So I take this opportunity to share my experience in the journey of optimization. Is it okay? Is it okay? Audio is fine? Yeah. Okay. So what I would like to say is, during my PhD, my area of research was some topics in nonlinear analysis. At the end of my PhD, I attended one international conference, like how Dr. Chittaranjan Malik organized. I attended one conference that was organized by Aligarh Muslim University. There I simply went and to present my paper. But fortunately, there were a lot of good mathematicians across the world, especially in the theory of optimization. Optimization, convex optimization, and large-scale optimization. A lot of people were there. Then only I could meet my postdoc mentor Professor R.T. Rockefeller. Then later I visited him at the University of Washington, Seattle. There I learned more about optimization, but still my journey in optimization was totally random. Without taking the fundamentals, without knowing the fundamental giving the proper foundation in the subject, I studied the topics through some research papers. Though I could guide some students in optimization theory, I struggled a lot in how to learn the optimization theory properly. Okay, so there only I learned that there is a systematic way of learning the optimization theory. So I'm sure what I'm going to present now will be of use to many people who want to know, because this is the order of the day, because of the trends in machine learning and the data science. At every step, the convex optimization is involved. You take any algorithm in machine learning that involves one optimization inside. So in order to learn the optimization properly, let me just share just a few minutes only. Yeah, hope you are able to see. Are you able to see my slide?
Yes, sir.
Yeah. So thanks to the organizer for giving me this opportunity. So how to learn the optimization? So if we read through papers, we will never achieve where we want to go. So the basics for optimization, you should be the multivariate calculus, you should be very thorough with. Okay, what is the meaning of, for example, an operator from Rn to Rm, how to represent the Jacobian, and if mapping is from Rn to R, how to represent the second derivative, the Hessian operator, all that we should learn very thoroughly. So therefore the linear algebra also is playing a major role, especially the matrix theory, that is the eigenvalues and the positive definite matrices, all that we need a lot of information about the linear algebra, and also a little bit about the geometry, that is linear varieties, and also I should say this how to understand the hyperplane and the polytopes, so that we can give a strong foundation for linear programming. And also more importantly, in the recent trend, if you try only theory, it is of no use. You have to get the feel of the Python, through the Python, the feel of optimization through the Python language. It is very easy to learn. You don't need any teacher for this. So we have to, first of all, just suddenly if you start with any general optimization, it's very tough to read. Some basics about the one-dimensional optimization. First of all, some of you might have studied in numerical methods, golden section, bisection, Fibonacci method, Newton's method, and the secant method. How to do the search in the one-dimensional case, and then the multi-dimensional case, the unconstrained optimization. I feel that everyone should start with the gradient methods, the steepest gradient, and the convergence analysis. What is the algorithm? How to implement the algorithm through Python, and the Newton method, conjugate gradient method, Quasi-Newton method, and also how to solve the linear equations. Solving linear equations through the least squares method. And there are some methods, the global search method, which doesn't involve the derivative concept. Okay, so So those a little bit you should know about the global search methods. And then the linear programming. We should master the basics of the linear programming, simplex methods, revised simplex and dual simplex method. The power of the duality. That means to look at the same object in two different angles. And also integer linear programming. For the first time reading, we can omit this integer linear programming, but later if needed, we can go through. And then I learned this non-linear constraint optimization. So many people suddenly they jump into this non-linear constraint optimization without knowing all the previous things. There only the difficulty comes. So the equality constraints, inequality constraints. First of all, we should be familiar with the Kuntaker conditions with the equality, the Lagrange multiplier method with the equality constraints, the inequality constraints with the Kuntaker conditions, and the convex optimization. So the convex optimization should be your ultimate goal, where it has lot of applications in every algorithm of the machine learning. And also we should how to solve the convex optimization problem. There are a lot of algorithms. One is the projected gradient method, Lagrangian method, and the penalty method. These are all very well-known methods for convex optimization. And the last one is the multi-objective optimization. This is depending on your need. The uncertain linear programming problem, and how to solve the multi-objective problem by converting the multi-objective to the single objective, and understanding the Pareto solutions is very important here. And I would say that the books what I use for learning the optimization, the general nonlinear programming and linear programming. So the number one, I would say this Belzekas, published by Ethera Scientific. Yes, it's totally non-technical because this is written by a professor of electrical engineering. And another book I would suggest, I suggest only 3 books. Nonlinear programming by Belzekas, and this is a very well-known book, Convex Optimization by Stephen Boyd and Vandenberg. This Boyd's lecture notes and video lectures are available in Google. Okay, you can just YouTube, you can just download and you can watch, you can learn the convex optimization. And number 3, I learned many things thanks to this book, An Introduction to Optimization, Chang and Zach. Okay, a 4th edition. This is a very nice book. I would more than if I compare with the previous 2 books, I would suggest for any new reader, if I want to learn seriously operations research, the optimization, the best book is An Introduction to Optimization by Chang and Zach. He has given all the details, including the basics needed for this book, for learning the optimization theory. And recently, very recently, the 5th edition has come. The 5th edition, the newly added chapters are the machine learning algorithm. So the title of the 5th edition book is Introduction to Optimization with Machine Learning Applications. I am sure that this book is available. This book it is available even on Amazon. You can, if you want to seriously, if you want to read the book, you can buy this book, Introduction to Optimization, 5th edition or 4th edition. 4th edition is enough to learn the optimization, and machine learning applications. You can. There are a lot of books available, and one of them is the 5th edition of this book. And so these are the basic things I wanted to cover. Let me stop sharing. So this is what I wanted to share about optimization. Those who are new, the research scholars or the MSc students who are here, if you want to learn, this is the best book available, the Chang and Jack, I would suggest. And this is the systematic way of learning the optimization theory. So with this, I am done. Over to Dr. Chittanandan Malik. Any questions? I'm sure the conference is going well. Hello,
Hello, sir.
Chittanandan. Yeah, yeah, yeah. Yeah, yeah, fine. Yeah, yeah.
Hello, sir. Good morning, sir. My voice is audible, sir. Okay. Sir, the screen is visible. Sir, the screen is visible, sir. Hello, sir. Good morning, sir. Sir, I am. Good morning, sir. I am a. I am a research scholar of. I say Anupam Pradhan. I am a research scholar of Deputy Rautala, Odisha. My guide is Dr. Jayant Kumar Das, Department of Mathematics, IMIT, Kotak. Sir, I am a research paper using a new method to solve multi-objective, multi-item fuzzy solid transportation problem. Next. This is introduction part is sir. The transportation problem is the second slide is the second slide is sir. Introduction part sir. That just transport. screen is visible? Sir. I am introduction. Introduction part is this, sir. Transportation problem is a methodology that is the entrance of good supply for multiple supply in cost effective, minimizing cost for various source to various destination. So the transportation problem is to a part of solid transportation problem. It is the involves to many factors to capacity into the transport good items of specific routes. There are multi-objective, multi-item solid transportation problem is good item in a mixture of classical and latest model of transportation problem. So the multi-objective, multi-item, solid fuzzy transportation problem in a phase of a just step adopt in rule, but what we like classical fuzzy set theory. It is the application is various context to contest out of fixed application and uncertain and varied demand, supply, cost, and data. So just like a decision making process in current scenario. Next is sir. Second, second, continue sir. Second sir, second part is visible. Sir. Second part is sir visible. Continue the Kundu the introduction part continue. Kundu highlighted two methods and one master's diffusion method and one focusing of concept of mini fuzzy number and second is Chakraborty is focused to the second fuzzy inequality type and that deals with the restriction of product quantity shift with the source or to destination in the capacity of route availability. Then Wing Cheng Cheng Link and Wing Cheng Link is tried to present, designed to goal a contest of uncertain market, then the market demands probability for the description of fuzzy sell and buyers. Beat et al. Represent the conflicting of picture, supply and demand capacity, adopting the fuzzy application. And it is the fuzzy application is that probability focus escapably use the nonlinear optimization program in Macul to solve the uncertain and problem fuzzy probability. S. Nanda and K. Karo is the title focus the convex set theory, focusing on the development and study convex set the convex and fuzzy set mapping. Next is the preliminary part. Okay, sir? Sir, visible? Sir, hello? Second is the preliminary part. Preliminary part is contents on the most definition of fuzzy set and fuzzy number using multi-objective programming. First is fuzzy set. Fuzzy set is concept of mathematics and a logic. It is the used to situation where membership function is a binary. Binary means two. That is true or false using this statement. But rather involves the degree of membership. Unlike the classical sets, the elements belongs to the sets on the fuzzy sets. Partially it belongs to set with membership value is the fuzzy number 0 and 1. So if fuzzy set is inversal set, it is the order pair set. It is the notation is this. It is x is the element of inversal set of x and mu of x is membership function itla a and assign the membership value of x. Mu of itla x is equal to 0 means x is not a member of x. Then second is use is minimum fuzzy number. Minimum fuzzy number means Berkeley is the introduce the method find the minimum fuzzy number, use the concept of inventory control programming. Let b tilde be the fuzzy number and cy is the center of core, b tilde y and left length of y, right the length of y is the area under the membership function of the right CB center of core respectively. The minimum fuzzy number by is defined as minimum fuzzy number b tilde y is equal to maximum left y minimum center y minimum right y. So the means minimum fuzzy number can be determined the multi-objective optimization problem. Third is fuzzy probability. Third is fuzzy probability. Fuzzy probability means set, let S is the set for the random variable, the outcome of random experiment. Worm is the Borel set in delta is the subset of set S. Let the set the function P is function 1 to real number R satisfy the condition probability of A greater than equal to 0, then total probability of set S is equal to 1. Then if I varies from 1 to 8, the decision set is the total Ohm set, probability of union of J varies from 1 to n Aj sum is equal to summation of Ai is equal to probability of Aj. Third is inequalities. Inequalities is the fuzzy set theory. There are two part. Inequality is due to Berkeley and inequality is the S and non-docker. Berkeley is inequality. It is a partial order relation is the fuzzy number and real number. And inequality due to Nanda and Karo. Nanda and Karo it introduced the partial order relationship between fuzzy number. It is the define a partial order relation greater than equal to between the two fuzzy number a tilde b tilde using the minimum fuzzy number alpha code representing a greater itla b. If a is greater than equal to b, a is belongs to a tilde alpha and b is belongs to b tilde alpha. For all alpha is lies between fuzzy number 0 to 1. Then next is inequality due to Zimmerman optimization programming. The fuzzy probability real number. So the inequality A is greater less than equal to B, less than is P function. Then technique is this. Then next is multi-objective programming. What is multi-objective programming? Multi-objective programming is known as multi-objective optimization, spectra optimization or vector optimization. It is a mathematical optimal technique that involves the optimization multi-objective function. Simultaneously, single objective optimization where the goal is find the best the solution of maximize or minimize a single objects. Multi-objective programming aims to find a set of solutions that represent the best possible trades-off between conflicting objectives. Then how to solve the new method, solve the multi-objective, multi-item fuzzy solid transportation problem. Then in this part, multi-objective, multi-item fuzzy solid transportation problem, you will solve the new formulate in this model, that is I is the index of sources, J is the index of destination, K is the index of convex, and P is the index of items, T is the index of objective, AIP is the total amount of product of item P at sources, BJP is demand of products of item P at destination J, EK is the total transportation capacity of convex K, CIJK TP is the cost of transporting one unit of item P from source I to destination J by convex K K. Xijk is the amount of item P to be transferred from source I destination to J by the with the aid of convex of K. Then next is what is the transportation cost. The multi-objective multi-item fuzzy transportation problem with the P objects in which L distinct items are carried from N sources to M destination by R different convex. So, if the transportation activity occurs, the transportation cost will be paid proportionally. In such the case, the transportation clause is constructed to function ftx summation p1 to n number of objectives, then the number of sources, then number of destination, then number of convex. Cijk into xijp and t is the 1 to up to t. Next is it is the construction of model constructs. How to multi-objective items using model constructs. The first constraint of the model is the total carried from source L is not more than AIP. Thus, we obtain summation j varies from 1 to n and summation k varies from 1 to n xijk at less than AIP, where L is equal to 1 to up to n, P is up to 1 2 3 up to n. The second constant is the model, the total quantity carried from source should meet the demand of destination J. Thus, we obtain summation I varies from 1 to n, summation k varies from 1 to r, xijk greater than equal to BJP, where J is equal to 1 to M and P is equal to 1 to L. The third constant of model is the total quantity carried by convex K is not more than the transportation capacity. Thus, we obtained summation P1 to L, summation I1 to N, summation K1 to R, Xijk less than equal to convex Ek. K is 1 to up to R. Using the above notation, the multi-objective multi-item fuzzy transportation problem can be followed as the new form minimum function ft is equal to summation p equal to 1 to l, summation I equal to 1 to n, summation j equal to m to m, summation k equal to n, xij kt n into xij p. T is vary from 1 to t. Then subject to constant. Subject to constant is using the model constant. First constant is summation j varies from 1 to m, summation k varies from 1 to r, xij k p
Yes, sir. I had a question.
Hello, excuse me, sir. I'm audible? Yes. Sir, namaskar. Sir, namaskar. She's getting. No, no, sir. Actually, LP Maharana is now getting ready. She's just trying to join. Just a second. Yes, sir. Yeah, sir. ନା ନା ସାର୍ ସେ ଜଏନ୍ କରିଥିଲା ତାର କଣ ଲିଭ୍ ହେଇଗଲା ସେ ସେଥିପାଇଁ ରିକ୍ୱେଷ୍ଟ କରୁଛି ଯେ ମତେ କାଇଣ୍ଡଲି କୁହନ୍ତୁ ଆଉ ଥରେ ପିକ୍ କରିଦେବା ପାଇଁ ଓକେ ସାର୍ ଥ୍ୟାଙ୍କ ୟୁ
Uh, yes, sir. Yes, sir. Actually, sir. Yes. Sir, is it visible? Yes, sir. Yes, sir. Now, sir. Hello. Hello. Okay. Good morning to all. I am Dr. Ranu Singh, currently doing my postdoc from Indian Institute of Technology, Bhubaneswar. So my presentation topic is on a proposed computational procedure for stationary probability in a batch service queue with infinite buffer and deterministic service time, like GIDAB1 infinity model. Here GI represent general inter-arrival time distribution and DAB is bulk service process but deterministic service time. So these are the outline of my presentation, and first I will discuss about GID1 model and then I will discuss about GIDAB1 model. So the model first is GID1 model with single and multiple working vacation policy. So the objective of this model is to analyze GID1 model with single and multiple working vacation policy and to derive the stationary system length distribution using Markovian approximation and Padé approximation and also apply the root method. Here we evaluate the performance metrics such as mean system length and waiting time under different vacation policy. And lastly, I connect the model with practical implications where single server handle demand from multiple sources. So these are the literature review. A lot of people have worked on various models like GID1, GIDC, MM1 model, but no one had touched this model with working vacation policy. And The second model is GIDLV model. So no one have touched bulk service process. So these two model I will discuss here. So here GI represent general independent distribution, and lambda and eta are mean arrival rate of customer during normal and working vacation period. Actually here there are two phases. One phase is normal phase and one is working vacation phase. When there is a customer in queue, the server is working as a working vacation, normal phase. And when there is no customer in the queue, service in vacation period, and it works with the intensity denoted by rho equal to lambda d1. Here are some notations like NST minus represent number of customer in the system, and minus represent here I have look the system at pre-arrival epoch, means just before arrival, and epsilon t minus represent the when it will 0 it is in working vacation phase, when it will 1 it is in normal service phase, and the Pn0 is probability that n customer in the system just before an arrival, and the server 0 represent the server is in working vacation phase, 1 represent the server is in normal service phase. Here we define some probability like how servers serve. BA represent the probability that I customer serve during working vacation period. So there are three possibilities. One, number of customers served during working vacation period, number of customers served during normal phase period, and one possibility that server is in vacation and the server switch to working to normal service period. So CI represent that probability. After examining the state of two consecutive embedded market point, we found the transition probability matrix. So here I will not go in detail about this due to time. So this is a transaction probability matrix. And after getting transaction probability matrix, we can directly write the set of balance equation for the stationary probability distribution at two successive pre-arrival instances. So this is the set of balance equation. After getting balance equation, we can easily write probability generating function. So here we write the probability generating function, and to solve this probability generating function, we use the techniques developed by Chaudhary et al. 1983, that is the root method. So here we find the root of the denominator and use the Chaudhary et al. Techniques and write it into the partial fraction form. Once we get root of the PGF, we can easily write it into the probability generating partial fraction form. And here there are three unknowns, so and two equations. So we use the normalizing condition to get another equation and solve all these equations and get the stationary probability. This is for stationary probability for pre-arrival epoch, means just arrival epoch. Now I am discussing about arbitrary instance, system length probability at arbitrary instance. So Chaudhary and template 1983 develop a relation in between system length distribution at any instant to just before arrival instance, and Banik 2027 gave elapsed inter-arrival time stationary distribution. So we use this and directly get the system length distribution at random instance, and apply the same approach as we discussed earlier, like root method, to find the system length distribution. Once we get the system length distribution, we can easily analyze the performance measure like mean system length and mean waiting time. Mean waiting time is done by Little's law. After that, I converted my model into the without working vacation because I want to validate my model with previous study. So I just without working WWV means without working vacation, converted it into without working vacation and checked my model with Banik et al. 2022 model here x equal to 1 with probability 1 and C means number of server. I have worked on server. I have taken one server. So here I check the model with one. So we get a similar result, approximate. Here I have taken the example like along 5 phase distribution and okay. So these are the numerical analysis for multiple working vacation, and this is the sensitivity analysis like traffic intensity between what happen when traffic intensity goes low to high. This is the numerical illustration for single working vacation, and this is the sensitivity analysis. This is the application, like how this model work for a repairable component. When faulty component comes here one by one and the repair center go to repair. Once there is no faulty component in there, the server is in working vacation phase. Not totally shut down, but it works like reduce rate. And when there will be a customer in the queue, it will work like a normal service phase. This is the conclusion. So I have here discussed GID1 model for single and multiple working vacation policy and discuss the performance matrices and demonstrate the impact of vacation policy on queue behavior through numerical example. And now GIDAB model. So here only difference is this is bulk service model. So here DAB model like DAB means it is operate like a general bulk service rule. Means the server begin service only when at least a customer and in the queue, and it can serve up to B, means upper limit is B and lower limit is A. Before that, the server is in ideal phase. So I am working on this problem, and this is the setup balance equation. So the numerical illustration is under process, so I have not shown here. These are the references. Okay. Okay, thank you, sir.
Yes, sir. Yes, sir. Yes, sir. Good afternoon, everyone. Uh, my name. Okay. Good afternoon, everyone. My name is Dibranjan Rana, and today I'm going to present about fabrication and characterization of aluminum alloy 7075 aluminum matrix composite using bottom pouring star casting method. Here, fabrication and characterization means the process of creating a material followed by uh, details analysis of understanding its properties and the structure. Okay. Then the outline. Here, these are my contents which I am going to present. First of all, the introduction, the objective of the current study, experimental setup, result and discussion, and then conclusion. Okay, introduction. What is composite material? Composite material is formed by the combination of two or more different materials which combine together to generate the enhanced properties of the developed material. For example, you can see, for example, the bar is the reinforcement, and the matrix has the good shear properties. Okay, then if it combined together, the composite is formed. Then what is stair casting? Stair casting is the liquid state method of composite metal fabrication in which a dispersed phase is mixed with a molten metal employing the mechanical stirring. It is one of the simplest and most cost-effective method for fabrication metal matrix composite. Then objective. The objectives are to fabricate the aluminum alloy 7075, titanium diboride, aluminum matrix composites with the 6, 9 and 12% titanium diboride reinforcement. Then to characterize its mechanical properties such as tensile strength and the hardness. Then to study the microstructure and mechanical properties of the composite. Then this is the experimental setup. The table one shows that the chemical composition of aluminum alloy 7075. Then the table 2 shows that the process parameter of the stir casting process. Then this is the chemical reaction. These are the chemical reaction taking places in the in situ process. And the diagrams shows that the 6%, 9% and 12% reinforcement then the result and the discussion. The result are the XRD analysis of the composite material, microstructure analysis of the composite material, tensile strength, microstructure analysis, micro hardness analysis, factography analysis. Okay, this is the XRD analysis. In the XRD analysis, we can see the titanium diboride percentage increases. Hello. Hello. Okay, okay. Then the microstructure analysis. These are the pictures of the microstructure analysis of the composite material. Here you can see the titanium diboride and the aluminum matrices. You can see here the diagram A shows the 6% composite, and the diagram B shows the 9%, and the diagram C shows the 12%. Thank you, sir. Then the tensile strength analysis. Tensile strength analysis shows here the two diagrams shows that the diagram A shows that the that the UTS means the ultimate tensile strength increases according to the reinforcement percentage increase. Then the diagram B shows that the elongation decreases according to the reinforcement increases. Okay, the micro hardness analysis. Here, the micro hardness analysis shows that the micro hardness increases according to the percentage increase of the reinforcement. Then it is the factography analysis. Then the conclusion. The-
Good afternoon, sir. Yes, sir. Yes, sir. Good afternoon, everyone. This is Akanksha Pradarshini Maharana. Today I will be going to present my project on the topic entitled by Formulation and Optimal Solution of a Fuzzy Decision Making Linear Model with Application in Healthcare under the guidance of Dr. Anuradha Sahu. So, here are the main sections I will be covering today. We know there are many uncertainties in healthcare, like in resources such as beds, staff, and equipment, which are depend on patient demand. So the fuzzy LPP model helps address those uncertainties by combining fuzzy logic with linear programming. This model allows healthcare system to make optimal decision even with incomplete information. So here are the literature review for my project work. Okay, okay, sir. Sir, is this visible? Yes, sir. Now it is full screen. Yes, sir. I'm. Sir, now is this visible? Sir- Okay, sir. No, sir. Yes, sir. I was doing. Sir, but is this visible now? Yes, sir. Here are some literature review for my project work. These are some main key concepts that are relevant to my project work. First, we know about decision making problems. So decision making problem involve the process of choosing the best option from a set of alternatives. These are the key components. Uh, Next is optimization problem. So it involves finding the best solution from a set of feasible alternatives. Next is fuzzy set. So we know what is fuzzy set. A fuzzy set is a type of group or collection where the items can belong to it partially rather than fully or not at all. So this is the definition of the fuzzy set. Now let's take an example to understand what is fuzzy set. Suppose we take here height and the fuzzy set here is tall. So if the height is 160 centimeter, we say it's not tall. And if the height is 170 centimeter, we call it somewhat tall. And if the height is 180 centimeter, we say it's definitely tall. And if the height is 190 centimeter, we say it's very tall. I presented this with a membership value to show its fuzziness. Next is membership function defined as mu a where x belongs to 0 to 1 is a function that assigns to each element membership value which indicates the degree to which x belongs to a. If the mu x means the membership value is 0, that means x does not belongs to the fuzzy set A. If the membership value is 1, that means x is fully belongs to the fuzzy set A. And if if it between lies in between 0 to 1, then x partially belong to A. Then we comes to the fuzzy number. There are we qualify as a fuzzy number. To qualify as a fuzzy number, a fuzzy set A on R must possesses the following properties, that is normality, convexity, piecewise continuity, and boundedness. Next, we know about the alpha cut of a fuzzy number. For a fuzzy number A on R with a membership function, this alpha cut is a crisp interval where L alpha is the lower bound and U alpha is the upper bound. In the set A alpha, we say the set containing those elements where the membership value is greater than equal to alpha. Next is types of fuzzy number. There are various types of fuzzy number we know, but here I will explain only about the triangular fuzzy number. The first know about triangular fuzzy number. A triangular fuzzy number characterized by a triangle shaped membership function. It has three parameters, that is A, B, and C. This is the membership function of a triangular fuzzy number defined as this. And then we know about alpha cut of a triangular fuzzy number. For a given alpha which is belongs to 0 to 1, The alpha cut of a triangular fuzzy number A, denoted as A alpha, is the set of values x belongs to the. Okay, sir. Okay, sir. For our project work, we have formulated a model below. Suppose a hospital in USA wants to allocate its limited ICU beds to two types of patients, that is critical patient and non-critical patient. We have to minimize the resource cost while ensuring care for all. The hospital faces uncertainties in both resource requirements and available resources, which are modeled as fuzzy constraints. Here, X1 refers to number of ICU beds allocated to critical patient. X2, C1 is cost coefficient of critical patient. C2 is cost coefficient of non-critical patient. Here, we here we given a model to understand our model below. This is the methodology which is we use to solve that model. Here we graded mean integration. This is the formula of the graded mean integration. By solving, we get this formula. Then the deterministic equivalent of that previous model given by the following decision making crisp linear programming problem. This is the crisp interval after solving with graded mean integration. This is a numerical example. Uh, Suppose a hospital, that is we I said before. Here I take some numerical values for ICU bed for non-critical patient. I take $500 for the per bed for critical patient. For non-critical patient, I take cost of ICU bed $300. Total beds available. This is the fuzzy. This is the fuzzy value, which is 80, 90, and 100. And critical patient demand. This is also a fuzzy value, that is 50, 55, and 60. And non-critical patient demand is 20, 25, 30. Here is the our optimization model. That is, we have to minimize the cost, and these are the subject to given constraints. By the graded mean integration, we solve that fuzzy values to make it a crisp value. Like before, we the here we this is the crisp value after solving, and here I take alpha is 0.7. uh, by solving it by Lingo software, I found the solution of constant x1 for critical patient demand is 55, and for non-critical patient demand x2 is 25, and the total number of beds we got 80, which is less than the available 90 beds. So this is the feasible solution, and by the minimizing cost, we got the objective value, that is Z, which is $35,000. Now we make the decision by observing the solution that the optimal solution is to allocate 55 ICU beds to critical patient and 25 ICU beds to non-critical patient with a total cost of 35,100. Now, at the end, we get the conclusion that the fuzzy optimization model successfully minimized the resource allocation cost. So this is the future scope. In the future, we will work on fuzzy nonlinear optimization model and multiple objectives at once. These are the reference. Thank you.
Yes, yes, sir. Yes, sir. Sir, am I audible? Okay, sir. Sir. Sir, is my presentation visible? Okay. So good morning one and all present over here. My name is Anjan Kumar Mishra. I am from Department of Mechanical Engineering, PMEC Berampur, and I am going to give a presentation upon effect of silicon carbide particles on thermal, microstructural and mechanical properties of friction stir processed aluminum alloy 6061 T6 plate. These are going to be my contents. Starting with what is a friction stir processing. Basically, the principle of friction stir processing is based on friction stir welding technique, and this FSW is used for welding difficult to weld materials, which is basically used in automobile and aerospace industries. What we do in FSW, the non-consumable tool which is rotated against the two facing workpieces without melting the workpiece material. Basically, the friction is generated between the rotating tool and the workpiece interface, and because of the friction, heat is generated, and it will weld the material by plasticizing it in the stir zone. And that is why it is considered as a green fabrication process, because it required very less amount of heat input and does not generate any kind of dangerous fumes, gases and rays. And moreover, the basic welding defects like porosity cracks are also absent in this FSW. So if you will see the current scenario in industry, the broader requirement of industries is stronger, lighter and low cost material, for which the metal matrix composites were introduced first. But after that, upon research, we see that most of the defects are generated from the surface itself, like wear and tear or any kind of cracks that is basically developed on the surface. So that is why the surface properties of the material must is the prior or the foremost concern for increasing the life of the product. So that is why the surface modification should be there, and in this or in FSB we are modifying the surface by impregnating the hard ceramic particles into it. So for that we have to see what are the different reinforcement strategies that we are following. So as you can see in this figure number 2, there are different types of reinforcement strategies, like directly pasting of those particles on the surface, packing of the particles on the groove cavity that is created on the parent material, then packing of the particles in net of blind holes that is being created on the parent materials. Among all these processes, the grooving technique is mostly used, and this is basic or very easy technique to a technique for reinforcement strategy. So now in our experiment we have used the base material as aluminum alloy 6061 T6 aluminum plate having thickness 6 millimeter, and obviously the chemical composition and mechanical properties are also shown in table 1 and table 2. And why we have used this material? Because of its some properties or like excellent thermal conductivity, corrosion resistance, high strength to weight ratio, then good castability and lower density. And for reinforcement we are using silicon carbide particle having particle size 1 to 40 micrometer, and it is also having some excellent properties like outstanding thermal shock resistance, high thermal conductivity, excellent wear resistance and high strength hardness, low density, and obviously it is available easily. Now you can see in the figure number 3, this is the base material that we have used, having dimension 150 mm in length, 120 mm in width and 6 mm thickness. And at the center line of this particular base plate we have created one groove or a square groove of 3 millimeter. Now if I will explain my experimental setup, we have used, obviously I have already told you, that groove technique for SIC insertion. Then as you can see in figure 4a and b, we have used two tools. First tool, that is a pinless tool, H13 tool steel with an 18 mm shoulder diameter, which is basically used for capping of those silicon carbide particles or capping of the silicon carbide powder into that particular groove or top surface of the groove. Then after capping, we are using the final FSP basically on a sophisticated FSW machine setup. That figure you can see in figure number 5, and also by using H13 tool steel, but here with a concave shoulder of 18 diameter and a taper threaded pin profile with a pin length of 5.8 millimeter. And we have taken constant machining parameters like the rotation of 1100 rpm and traverse speed of 1.5 millimeter per second and 2-degree tilt angles. Then we are going to do the test like ACM, then EDS analysis. Then we are going to test the micro hardness and tensile testing. Now, basically here in this experiment, we have used the multi-pass friction stir welding. That means we have basically gone for 4 passes of this friction stir processing. So first we have done the thermal analysis, and for thermal analysis we have taken a K-type chromal aluminum thermocouple of 15 gauge AWG, and we have inserted this particular thermocouple at a depth of 3.5 millimeter and 14 mm distance from the center line. And after getting the result of this thermocouple, we have seen that as we have gone for 4 passes of FSP. In the first pass, the peak temperature for advancing side is basically 339.67 degree, and the retreating side is 334.03 degree. But after the end of the 4th pass, the temperature is being decreased. That is for advancing side, it is 312 degree point 81 degree Celsius, and for the retreating side, it is 303.72 degree Celsius. So we can say that the temperature basically decreases with more passes due to the reduced plastic deformation. Okay, by pass, basically the plastic deformation is being reduced because of the uniform material flow. In the pass number 1, basically there is non-uniform material flow, and particularly in the advancing side. So that is why if you will compare between the advancing side and retreating side, advancing side shows more temperature as compared to retreating side. So this is the graph that we have plotted for different paths. So as you can see, advancing side is basically showing a higher temperature as compared to. Yes, sir. Yes, sir. I will complete. I will complete, sir. Advancing side is basically showing higher temperature as compared to retreating side, and as you can see, as the passes or we are increasing the passes, the temperature or the peak temperature is decreasing. Now, in the macroscopic analysis, we have as the image you can see different passes or 4 passes that you can see, and you can see clearly the rubbing action of the rotating tool shoulder on the workpiece, creating a semicircular geometry emerges as a crown. Okay, so it is known as a crown, and basically it is showing no flaws and irregularities in this present experiment. So for microstructure analysis, we have used the SEM analysis. So as you can see, those grain structure. Hello, sir. Okay, sir. Okay, sir. Okay, sir. So basically, I conclude my presentation that multiphase FSP improves the properties and SI because of the SIC reinforcement, and obviously the future scope is to optimize all those parameters for improved performance. Thank you for listening, sir.
Yes, sir. Yes, sir. Yes, yes, sir. Yes, sir. Okay, sir. Okay, sir. Thank you. Yes, sir. Is it visible, sir? Okay. Okay, sir. Good afternoon, all. Now I'm going to present a paper on performance assessment of vegetable oil waste nano cutting fluid in MQL and float cooling system for sustainable hard turning of AISI 304 steel. My paper is it is 6.3 and I am from Department of Mechanical Engineering IJD Sarang. So these are the content: introduction, literature review, objectives, methodology, experimentation, result and discussion, conclusion and references. Introduction. The basic use of cutting fluid is the cooling and lubrication, but better exposure of the fluid causes skin disease and cancer in workers. So minimum quality lubrication refer to the use of cutting fluid that is 3 to 4 times lesser than the amount we commonly use in food cooling system. So MQL system that uses limited amount of coolant applied, and it is a promising solution because of using nanoparticles in emulsified fluid. Nanofluids are the fluids in which nanometer sized particles are perfectly distributed in the basic fluid. So here the cutting fluid have many disadvantages for which MQL has gained the importance. So this is the literature, and objective of this research is to compare the performance of the oil, which is based on the vegetable oil and nanoparticles under varying cutting conditions, by measuring the temperature and the surface roughness. Methodology: nano molybdenum disulfide powder is mixed with coconut oil with the help of the ultrasonic bath sonicator. Then the soluble oil is mixed with water in 20:1 ratio to form the emulsifier oil as the base fluid. The nanomolybdenum disulfide powder is taken 0.3% of the coconut oil. Sodium benzene didosybenzene sulfonate is the surfactant used to make the nanoparticles stable in the oil. It also helps as emulsifier. The emulsifier oil contains 95% of water, and by sedimentation technique the stability is checked. So this is the preparation of the nano fluid. So the surfactant is used only to make the nanoparticles more stable. So this is the sedimentation test of the nano cutting fluid. So this is the stability of the mixture can be seen by taking the sedimentation method. So if the particles are not moving downwards, then it is said that the mixture is stable. This is the material details: nanomolybdenum disulfide, emulsification oil, coconut oil is taken as the emulsification oil, then hardened steel AISI 304 steel, then the carbide tool is used. So the machining is carried out on the lathe machine. AISI 304 steel is machined at different cutting conditions. There are 3 types of cutting condition has been chosen, that is the dry machining, float cooling, then MQL cooling. Then the cutting temperature is also measured using the embedded thermocouple technique, that is a K-type thermocouple is installed in the tool holder to touch the tool bit at the bottom. Then surface roughness of the machine surface is measured using the Mituto's surface roughness tester. And this is the machining condition. Here the machining is carried out for 12 number of setups. The cutting speed, 2 cutting speeds has been chosen, that is 65 and 45. Then depth of cut 0.5 and 0.25, feed 0.14, and the machining type is dry, float cooling and MQL. So this is the schematic representation of the experimental setup, and here is the machining of AISI 304, and this is the machine workpiece. This is the tabulation of temperature and surface roughness. After the machining, the temperature is measured, and this is the R and RZ value. So the cutting temperatures are low for the nano cutting fluid. MOS2 attains the layered lattice structure at the nano level, and sulfur atoms when exposed to the metal surface during the machining, that result in strong adhesive forces resulting in formation of persistent lubricant fill. So this phenomenon leads to reduction in friction. The coconut oil is oil in conjunction with the Fullerene structure of the NMOS2 imparts moderate viscosity to the nanofluid. The moderate viscosity adds in heat dissipation from the machining zone. So here the temperature is minimal for the 45 for the speed of 45 meter per minute and for a feed 0.14 mm per revolution, and for the depth of cut 0.25 mm per pass when compared to the other combinations. So these are the graphs obtained from the surface roughness tester. So at the speed of 65 meter per minute and feed of 0.14 mm and the depth of cut 0.25 mm per pass, it is found to reduce the surface roughness. And taking to the temperature in consideration, it can be concluded that the dry machining has more temperature value than the float cooling and MQL cooling. Then MQL cooling temperature is less because of the nanomolybdenum disulfide and the vegetable oil used with it. The temperature is also affected due to the spindle speed and the depth of cut as the feed is taken constant. So here the surface roughness is good at the cutting speed of 65 meter per minute, depth of cut 0.25 mm when the nano cutting fluid is used in MQL cooling system. So here is a conclusion. Optimum cutting conditions are found to be 45 meter per minute, depth of cut 0.25 mm and 0.14 mm per revolution for reduction in cutting temperature. The surface of to be minimum at the per minute, depth of cut 0.25 mm and feed rate of 0.1 revolution. So vegetable oil used in machining is friendly as less amount of feed is used. The disposal problem does not occur. The risk of skin problems like the is minimized. So here is the